Part B says that we are given a circle 2x squared plus 2y squared minus 8x minus 5y minus 1 equals to 0. And the point of tangent is 1 and negative 1. If you look at this equation, the coefficients of x squared and y squared are not 1. Okay, they are 2 and 2. And here there is no restriction. The only place where you have a restriction is when you want to find the center and the radius. When you know that you are going to find the center and the radius, it means that you must make the coefficients of x squared and y squared both 1. But if you are not going to find the center and the radius, you can use them the way they are. So because here we shall not find the center and the radius, we shall leave the equation the way it is, without dividing all the terms by 2 to make the coefficients of x squared and y squared 1. So let me sketch the circle here to guide us. And then let me draw my tangent there, assuming the tangent is coming from point B. These coordinates given as point C here are not the coordinates from where the tangent is coming, but they are the coordinates of the point when the tangent is meeting the circle. So this is the point they have called C. They have given us coordinates 1 and negative 1. I'm the one who created B, which is no offense, but they have created point C as the point of tangency. Okay, and then we know that we have the center and the radius, which is the distance, but we shall not find the center and we shall not find the radius. What do we need? That is very important. The key thing here is the gradient function of the circle. Gradient function of the circle. That is simply dy dx. How do we find the gradient function of the circle? Here we need to differentiate, okay, both sides of the equation of the circle with respect to x. That means we shall have dx of the left hand side, which is 2x squared plus 2y squared minus 8x minus 5y minus 1 equals to, we also differentiate the sides, which is 0, or differentiate that 0. So we are coming to differentiation now. If you differentiate 2x squared, what do you get? We get 4. We get 4x. We have differentiated the function in x, so we attach here dx, but we are differentiating with respect to dx still. Then the sign here is plus. If we differentiate 2y squared, what do we get? We get 4y. What is the function we have differentiated? Is the function y, but with respect to x. So dy dx. How about when we differentiate negative 8x, we shall get negative 8. The x will disappear, okay, when you are differentiating. If you don't know differentiation, please go and watch our list of videos. So we have differentiated negative 8x gives us negative 8. So it was a function of x with respect to x. So dx dx. If we differentiate a constant, 1 is 0. So we shall have here minus 0 equals to, if we differentiate 0, we also get 0. That means here, this are going to give us 1. It will cancel out. Therefore, we shall have 4x. Here. This dx and this dx will go, plus 4y dy dx plus 4y dy dx minus 8 is simply equal to 0, because minus 0 equals to 0 makes no difference. Now we need to make dy dx the subject. I've realized I've left out this term here. Yes, I've left out that term by mistake. I've left out minus 5. minus 5y. So if we differentiate, minus 5y shall get 5, but it is determine y with respect to x. And then minus differentiate 1 get 0 equals to 0. Mistakes. Now we're going to simplify. These are going to cancel. This will cancel. So we shall have 4x. Shall have 4x plus 4y dy dx. 4y dy dx. And then minus 8 plus minus 8 minus 5 dy dx equals plus minus 5 dy dx in that manner, and then equals to 0. So from here we need to make dy dx the subject, so we connect them together. That gives us here 4y minus 5 dy. It gives us 4y dy dx minus 5 dy dx equals to, I take the x, that side becomes positive 8, then 4x becomes negative. Here now gives us 4y minus 5, I factor out dy dx equals to 8 minus 4x. Therefore, dy dx here becomes 8 minus 4x out of 4y minus 5. So this is the gradient function that we are looking for. This is the gradient function of the circle at any point. That is the gradient function of the circle at any point. Now, what if we have point C? So at point C, which is 1 and negative 1, what is going to be the gradient? Now, so we substitute for x and y in the gradient function to give us the gradient at that point. At point C, which is 1 and negative 1, equals to 8 minus 4. What is x? X is 1 out of 4. Y is negative 1 minus 5. When we simplify, that gives us there 4 out of negative 9. So this is the gradient of the circle at which point? At point 1 and negative 1. That is the gradient of the circle at point C, which is 1 and negative 1. At the same point C, the gradient of the circle is the same as the gradient of the tangent. Therefore, the gradient of the tangent is going to be the same value, which is negative 4 out of 9. So how do we get the equation of the tangent? For us to get the equation of the tangent, we need to apply the formula for the gradient given by n equals to y2 minus y1 out of x2 minus x1. And on the point we have a 1 and negative 1. So let's call this x and this y. Then we substitute for them. Then we call them 1s. What is the gradient n? It is negative 4 out of 9 equals to, since I've called this one y1, we'll have y2 minus y1, which is negative 1 out of x2 minus x1, which is 1. And then from here, I make y the subject of the formula, so that it is in the form of y equals mx plus c. That is the equation of the line. And the tangent is a line. So what do I do here? I can cross multiply. So that if I cross multiply, I have negative 4x plus 4 equals to 9y plus 9. Then I make y the subject. That means 9y becomes equal to negative 4x minus 5. Therefore, my y becomes negative 4x minus 5 out of 9. And this is the equation of the tangent, which we can distribute the denominator so that we have y equals to negative 4 x out of 9 minus 5 out of 9. So this is the equation of the tangent to the circle at point C of coordinates 1, negative 1.